Hello everyone, welcome to my channel Nerdy Coder. If you're the first time seeing my video, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. In this video, I will show you everything you need to know to get started with using MongoDB. You will learn how to create databases and collections in MongoDB. You will also learn how to perform CRUD operations, create, read, update, and delete documents in MongoDB. I will also show you how to perform aggregation query in MongoDB. With an aggregation pipeline in MongoDB, you can perform queries similar to the group by clause in SQL databases. Lastly, I will show you how to check for performance of your queries and the importance of properly indexing your database to improve database performance. After going through this video, you will have enough knowledge to start using MongoDB as the backend database for your application. This video will also give you the fundamental knowledge you need to continue learning more advanced queries in MongoDB. Without any further delay, let's dive right into MongoDB. If you don't already have MongoDB installed, the quickest way to get started is to use Docker to run MongoDB. This is the simplest and quickest way to have a MongoDB running for learning, testing, and development. To install Docker, you can follow the instructions for your operating system from the Docker's official website. I already have Docker installed in my machine, so I will skip the installation process here. After you have Docker installed and Docker is running, the first thing you need to do is to pull the MongoDB Docker image from the Docker Hub registry. The command you need is docker pull mongodb/mongodb-community-server. Pull means to download an image from a registry. In most cases, this registry is the Docker Hub registry. MongoDB/mongodb-community-server is the name of the Docker image repository for MongoDB. If you're curious about where this image is in Docker Hub, you can go to the link here. To start the MongoDB server, you can run docker run --name mongo-p 27017:27017-d mongodb/mongodb-community-server latest. --name mongo means to assign the name mongo to the running container. -p 27017:27017 means to expose port 27017 from the container to port 27017 in the host machine. The first 27017 is the port in the host machine, and the second 27017 is the port from the container. By default, MongoDB server uses port 27017. -d means to run the container in detached mode, which is to run it in the background. And we want to run the latest version of the MongoDB image by appending the tag name of latest to the repository name. You can check MongoDB is running by typing docker ps. You can start MongoDB with docker start mongo. Mongo is the name of the container that you assign when you use the command docker run. And start MongoDB with docker start mongo. One way to interact with MongoDB is to use Mongo Shell, which comes with MongoDB. If you're not using Docker, you can start Mongo Shell by typing mongosh. If you're using Docker for MongoDB, you can start Mongo Shell by running docker exec-it mongosh. exec means execute command in the running container. -it means to start an interactive terminal. Mongo is the name of the container that we defined when we ran docker run. And mongosh is the command that we want to run in the container. To show all databases, you can type show dbs. You can see that there are already a few databases which were created by MongoDB. I'm going to create a database called REST API. To do this, you can simply type use parentheses REST API. MongoDB is very flexible and dynamic. If the database name already exists, it will set the database as the current database. If the database name doesn't exist, it will create one for you and set it as the current database. I'm going to create a collection named calculators. To do this, you can type db.create collection parenthesis calculators. A collection in MongoDB is like a table in SQL databases. MongoDB has flexible schemas, so you can create a collection even without defining any schemas. To show all collections, you can type show collections. Using Mongo Shell may be fine for simple operations like this, but as you are building more complex queries, Mongo Shell may not be the most user-friendly tool to use. I'm going to use the official MongoDB VS Code extension so that I can interact with MongoDB in VS Code through a GUI. My MongoDB VS Code extension is up and running now. I'm going to connect to my MongoDB instance through a connection string. The connection string is MongoDB //localhost 27017. Since we exposed port 27017 to the host through the docker run command, we can access MongoDB through localhost on port 27017. We can do the same thing in the MongoDB VS Code extension as in the Mongo Shell. For example, if you want to add a new database and collection, you can click here. This will open up the MongoDB playground, which is a JavaScript file. It will give you some pre-populated commands for you to edit. I will change the database name to REST API and collection name to calculators, and then run it. We already have the database and collection of the same names, so this wouldn't have any impact. You can also save these commands in a JavaScript file so that you can reuse it later. These commands are also valid Mongo Shell commands. You can copy these commands and run in Mongo Shell, and it will work just fine. Next, I will show you how to create documents in MongoDB. To insert a document, you can right-click on the collection name and choose Insert Document. It creates a JavaScript file with some pre-populated commands. The Use REST API command tells MongoDB to use the REST API database. The db-get-collection calculators command tells MongoDB to operate on the calculators collection. Another syntax to achieve the same thing is db.calculators. The command you need to insert a single document is insert1. It takes an object as an argument. The object represents the document you want to insert into MongoDB. Every document in MongoDB has an _ID field. If you provide an _ID field in the document, MongoDB will use this ID as the document's ID. The ISODate function is a helper function from MongoDB. It tells MongoDB that this is an ISODate string, and MongoDB will store it with a data type of date. If you don't provide an _ID field, MongoDB will generate an ID for you. This ID will have a data type of object ID. You can see that I used an ID of 100 in the first document I inserted, and it's reflected in the document. In the second document I inserted, I did not provide an ID, and MongoDB automatically generated an ID for me. If you insert a document with an ID and the ID already exists, MongoDB will give you a duplicate key error. To insert multiple documents, you can use the command insert many. It takes an array as the argument. This array is an array of documents. I have 7 documents here. And you can see that the document count has just increased by 7. This covers the basics of creating documents. Next, I will show you how to query for documents in MongoDB. To query for documents, you can click this magnifying glass here. This provides you with a few commands, but we will start from the basics. To get all documents in this calculator's collection, you can simply execute a find command without any argument. To find documents with matching fields, you can provide an object as the first argument of this find command. Inside this object, you can specify the matching field. For example, to find all documents with operator equals plus, you can do like this. MongoDB also has a number of query operators. These query operators give you more flexibility to define the matching conditions. For example, you can get all documents with operators equals to plus or minus using the in operator like so. You can also get documents with value greater than or less than a certain value. To get documents with result greater than 3, you can use the GT operator. To get documents with result greater than or equal to 3, you can use the GTE operator. To get documents with result less than 3, you can use the LT operator. And to get documents with result less than or equal to 3, you can use the LTE operator. If you want to get documents with an existing attribute, you can use the exist operator. For example, this will get the documents if this message attribute exists. You can also search for text with regular expression with the regex operator. For example, this will return all documents with the message field matching this regular expression. MongoDB also supports logical OR and logical AND conditions. For example, to get documents with either operator equals plus or result equals 1, you can do this with the OR operator. To get documents with operator equals plus and result equals 1, you can do this with the AND operator. Sometimes you only want to get a subset of the document. In this case, you can use projection in the find command. The second argument of the find command takes a projection object. You can specify which fields to include or exclude. If you only want to include the result and message fields in the response, you can do like this. You set the value of the fields you want to include to either 1 or true. If you want to exclude certain fields, you can set the field to 0 or false, like so. You can also sort the result. You can change the find command with the sort command like so. If you want to sort the document with the result field in ascending order, you can give a value of 1 to the result field here. If you want to sort in descending order, you will provide a value of -1. If you just want to count how many documents your query will give you, you can change the find command with the count command. This covers the basics of querying for documents. To update a document, you can use the update one command. If there are multiple matching documents, the update one command will update the first matching document. The first argument is the query object. This is the same query you will use in the find command. To update a document, you need to tell MongoDB how to update the document in the second argument. To add or modify an attribute, you will use the set operator. The value of this set operator is an object, which you can define which attributes should be modified. You can add a new field or modify existing fields. In this example, I will modify the error message to error : division by 0. As you can see, only the first matching document is updated. To remove an attribute, you can use the unset operator. The value of this unset operator is also an object. The key is the attribute you want to remove, and the value could be anything. In this case, I will use an empty string. The message attribute in the first matching document is now removed. Besides set and unset, there are other update operators. One example is the current date operator. If I want to set a timestamp field to be the current date, I can do something like this. The timestamp here is the timestamp attribute I want to set with the current date. To update all documents, you can use the update many command. The syntax of this command is the same as the update one command. The difference is that this command will update all matching documents instead of just the first matching document. For example, this command will set all matching documents with this updated message. This covers the basics of updating documents. To delete a document, you can use the delete one command. This command will delete the first matching document. The first argument is a query object, similar to the query object used in the find command. For example, this query object would delete the first matching document with operand 2 equals 0 and a division operator. To delete all matching documents, you can use the delete many command instead. The syntax is the same as the delete one command, except this delete many command will delete all matching documents. This covers the basics of delete operation. Besides CRUD operations, you can also perform aggregations to your data in MongoDB. There are several ways to perform aggregation on your data. The recommended and the most flexible way is to use aggregation pipeline with the aggregate command. An aggregation pipeline consists of multiple stages. A stage represents a particular operation on your data. Output from one stage goes to the input of the next stage. This aggregate command takes an array as the first argument. This array consists of one or more items. Each item is a stage in the aggregation pipeline. You can perform different operations at each stage. For example, if you want to sum all the results in your document and group by the operator, but you only want to include the result if the result is greater than 0, you can do this with this aggregation pipeline. In the first stage, you can filter out the documents by using the match stage. This match stage takes a query object. Using what you have learned earlier, you can use the GT operator on the result field. The output of this will be a list of documents with results greater than 0. In the next stage, you can use the group stage. This also takes an object. _ID is a required key. This is called a group key. This represents the attributes you want to group by with. In this case, we are grouping by operator. We need to use a field path here by prefixing the attribute with a $sign. By prefixing operator with this $sign, we are telling MongoDB that this is a path to the field operator of the input documents, but not a string literal of operator. To sum all results, you can define a new field named SumResult. You can sum all the results with the sum operator. And we are telling MongoDB to sum all values in the path of result by prefixing the attribute result with a $sign. If you want to count how many documents are there in each sum, you can add a count attribute in the output. I will name this count result. To get a count, we can simply sum a value of 1 for each document encountered. You can also group by multiple keys. To do this, you can set the group key, which is _ID, to be an object consisting of multiple attributes. For example, to group by with both operator and operand 1, we can do something like this. The keys OPR and OP1 are something you can define. It could be any valid attribute names. There are other aggregation stages you can use in an aggregation pipeline. For example, you can use the project stage to filter out the attributes you want to pass to the next stage. You can also sort the result with the sort stage. In this example, we are sorting by operator, operand 1, and then count result. If you only want to include the top 3 results in the output, you can do that with the limit stage. This takes a single integer. Let's cover the basics of using aggregation pipeline. Before I end this video, I want to show you the importance of indexing. Indexing allows MongoDB to retrieve data quickly without having to scan through all documents in the database. By default, MongoDB indexes the attribute _ID. If you're querying document by _ID, the query runs very quickly. You probably cannot tell any difference, but you can use the explain command from MongoDB to see more details. We'll use an argument of execution stacks to show execution statistics. The explain command will give you a number of different details. Under Query Planner, Winning Plan, you can see that it's using ID hack. ID hack is a performance optimization used by MongoDB to retrieve documents by ID. If you look under Execution Stacks, Total Docs Examined, you can see that MongoDB only needs to look at one document before giving us the result. We can try to query by operator and see what happens. We can see that instead of ID hack, it is now showing COLL scan, collection scan. If you look under Total Docs Assignment, it is showing that it scans 7 documents, which is all documents we have in MongoDB. It won't take much time to scan through 7 documents, but if you have 1,000,000 documents or more in MongoDB, scanning 1,000,000 documents for every query would be very inefficient. One way to improve performance is to add indexes to MongoDB. We'll use the create index command to add indexes. The basic usage is to simply add the attribute name with a value of either 1 if we want the data to be sorted in ascending order, or -1 if we want the data to be sorted in descending order. After you create the index, you can run the explain command again. And now it's showing IX scan, index scan instead of collection scan. And the total docs assignment is reduced to only 3. One caveat of adding indexes is that it will have a performance impact on write operations. Every write to MongoDB, we have to update the index data. Therefore, you should only add the minimum number of indexes needed based on your query patterns. I've covered the basics of using MongoDB. MongoDB provides a lot more capabilities than what I can mention in this video. If you want to learn further, the best way to learn is to reference MongoDB's official documentation. This is the video I wanted to share with you today. If you like this video and find this video helpful, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support. Goodbye and see you in the next video.